Mark these words. What's about to be put inside Tesla's cheapest car is something not even the most expensive models on the market today dreamed of. And it's no small detail. We're talking about a new brain, dubbed the Monster by Elon Musk, an artificial intelligence chip that not only replaces the previous one, but completely changes the way a car can think, act, and react in the real world. Its name? AI-5. And this little giant promises to make autonomous driving not only viable, but much safer than human driving. It may seem like an exaggeration, but the numbers don't lie. And what they reveal is something that could shake up the entire automotive industry once again. While the current hardware, called HW4, was already impressive in its capabilities, AI-5 represents a quantum leap forward. The new chip has 8 times more processing power, 9 times larger memory, and a 5 times greater bandwidth. This means fewer delays, fewer bottlenecks, and much faster responses, essential when dealing with split-second decisions, like braking before hitting someone or avoiding an unexpected obstacle. The difference here isn't incremental, it's structural. Elon Musk didn't call this chip a monster for nothing. He's literally rewriting the source code for autonomous driving, and in the brand's most affordable car. But the real shock isn't just in the raw numbers, it's in how AI-5 was developed unlike other automakers which buy third-party chips and adapt their systems. Tesla began co-designing its own chips with software in mind. It's as if, instead of buying a shoe and molding the foot, Tesla created the foot and the shoe simultaneously, aligned to the millimeter. This allowed complex functions, such as the infamous softmax of neural networks, to be executed in far fewer steps. The result? A system that interprets the world around it with much greater precision and speed. The AI-5 also shines in the use of mixed precision models, an advanced approach that alternates between different types of calculations to optimize performance and power consumption. This means that, even with intensive tasks, the chip avoids unnecessary overloads. Furthermore, it was designed to overcome one of the biggest obstacles faced by embedded AI systems, the memory ceiling. Where the HW4 stopped at 16 GB of RAM, the AI-5 can reach up to 144 GB. This huge difference is like comparing a simple laptop to a supercomputer. And in the world of autonomous driving, every extra gigabyte can be the difference between anticipating a risk or suffering an accident. It's no coincidence that experts like Morgan Stanley's Adam Jonas have called AI-5 a game-changer after 1,400-mile tests with the new FSD. We're not talking about a minor improvement. It's a complete reboot of the autonomous driving architecture. And the most impressive thing? This chip won't be exclusive to the Model S or X. He will be in the Tesla Model 2, the company's most affordable car. This breaks with the common industry logic, where technological advances only reach top-of-the-line models. Tesla is doing the opposite. It's democratizing high-level in-vehicle artificial intelligence. All of this raises an uncomfortable question. Would you trust a $21,000 car that thinks faster than you? Because that's exactly what the Model 2 promises. With AI-5, the car will be able to react to situations more stably, predictably, and, according to Elon Musk, 2 to 3 times safer than an average human driver. This changes everything. The perception of risk, responsibility in traffic, the idea of control. The car stops being just a vehicle and becomes an intelligent driving partner. And it's no longer a thing of the future. It's practically ready. For many, this change still seems distant, perhaps even risky. But what few realize is that, by putting AI-5 in a mainstream car, Tesla is forcing the market to react. Automakers still trying to copy the HW4 will now have to chase something 8 times more powerful. And this could create a domino effect. Pressure for proprietary chips, revised production strategies, and increased reliance on AI systems. In other words, AI-5 could change more than just the Model 2. It could change the entire industry. Most people still associate electric cars with two words: expensive and time-consuming. Expensive to buy, time-consuming to charge. But what if these two concepts are completely turned on their head? That's what's about to happen with the Model 2. The estimated launch price is just as $21,000, which puts it squarely on par with combustion engine models like the Toyota Corolla and Honda Civic. Only, in this case, with electric autonomy, onboard AI, and zero emissions. If that's not enough to raise alarm bells for traditional automakers, perhaps what comes next will. To reach this figure, something had to change drastically. And it did. The key to everything lies in the batteries. Currently, lithium-ion batteries are expensive, heavy, and involve a supply chain full of ups and downs. Tesla decided to bet on two new technologies that promise not only to reduce costs, but also to revolutionize the user experience. Batteries, sodium-ion and aluminum-ion. The first, besides being cheaper, with an estimated cost between $60 and $70 per kilowatt, it also eliminates the need for cobalt and nickel, two expensive and controversial elements. This move isn't just economic, it's also strategic. Sodium is abundant, cheap, and less unstable than lithium. This means that, in the near future, Tesla will be able to produce batteries on a large scale without relying so heavily on mining in countries with political or environmental instability. What's more, sodium chemistry is less prone to so-called thermal runaway, the uncontrolled overheating that scares many EV buyers. In other words, in addition to being cheaper, these batteries also tend to be safer for the common consumer. But it's with the battery's aluminum-ion that the game really changes. Although still in its early stages, early tests indicate that they can be recharged up to 80% in just 10 minutes. That's how long it takes to fill a gas tank. If this is confirmed on an industrial scale, the biggest problem with electric cars will disappear once and for all: waiting for charging. Imagine a $21,000 car that you can fill up almost as quickly as a gasoline-powered car, but at a much lower cost per kilometer. And it doesn't stop there. Aluminum batteries also promise energy density above 400 kWh, a number much higher than the 260, 210, 80 kWh of the most modern lithium-ion cells. This means that, with less space and less weight, it will be possible to store more energy. The direct result? Smaller batteries, lighter cars, and even lower prices. If one or both of these technologies are implemented effectively, the total cost of a battery could fall below $5,000, something unthinkable until recently. Combining this new generation of batteries with Tesla's aggressive cost-cutting engineering, the scenario becomes plausible. A car with cutting-edge AI, competitive range, and ultra-fast charging, all for $21,000. And the key to solving this equation lies in integration with Gigafactories. Tesla is optimizing every step of the way, from the materials used to the modular design, to minimize production costs and assembly time. This isn't just a new battery, it's a new manufacturing logic. Many manufacturers are still stuck in an outdated cycle, where each new model requires billions in investment to adapt factories and suppliers. Tesla is turning this logic on its head. First, it changes the technology. Then, it adapts production in a scalable way. And the Model 2 is the ultimate test of this strategy. If it delivers on its promises, other automakers will have to race to avoid becoming obsolete in record time. It's not just a cheap car with a new battery. It's a structural threat to the way cars are made and sold. This advancement in batteries also brings something that no one expected to see so soon in an entry-level car: performance combined with economy. It's not just about price, it's about delivery. Real value to the consumer, with decent autonomy, fast recharging, and a lower environmental impact. The combination of thermal safety, superior durability, and abundant materials positions these batteries as the next frontier of electric mobility. And all of this is being prepared for a car that costs less than a popular sedan. While other automakers are still welding, screwing, and gluing hundreds of parts to form a car, Tesla is already working on a concept that seems like something out of a science fiction movie: the Giga casting. Instead of assembling the car like a puzzle with hundreds of components, Tesla is fusing entire parts of the vehicle into gigantic pieces of aluminum. This dramatically reduces assembly complexity, cuts robot and welding costs, and dramatically speeds up production. And the Model 2 will benefit most from this radical approach. The proposal is simple, but bold. Build the Model 2 with the smallest possible number of structural parts. The rear end, for example, which would normally require up to 400 different components, will be cast as a single piece. The same goes for the front end, and eventually even the entire chassis could be cast from a single mold. This reduces production time, reduces the margin of error, and virtually eliminates waste. It's a logistical and industrial leap that could leave competitors 5 to 7 years behind. The Model 2's design was also strategically designed with this in mind. It will have a compact hatchback measuring approximately 4.2 meters long and 1.8 meters wide, ideal dimensions for European and Asian markets, where urban space is more limited. But don't think the look will lose that Tesla DNA. The model will continue with clean lines, fluid surfaces, and refined aerodynamics. With drag coefficient below 0.23, this isn't just aesthetics, it's practical energy efficiency, which is crucial for smaller vehicles. The factories chosen for this process also say a lot about the strategy. Gigafactory Mexico will be a major producer of the Model 2. Its location reduces export costs to the United States by up to 20% compared to exports from China. Furthermore, labor costs in Mexico are extremely competitive, less than $5 per hour, which helps to make the final price of the car viable. At the same time, Gigafactory Berlin will be the basis for distribution in Europe, taking advantage of local subsidies that can reduce $4,000 to $6,000 from the final price for the consumer. This industrial chess game is brilliant. Instead of relying on a single plant, Tesla spreads production according to target market and regional benefits. This means the Model 2 will not only be cheaper to manufacture, but also cheaper to deliver, and with fewer intermediaries involved, profit margins remain healthy even with such aggressive pricing. Meanwhile, other brands are still trying to adapt their legacy lines to meet new electrification demands. And there's more. If everything goes as planned, the combination between Berlin and Mexico could allow for an annual production of up to 1.5 million Model 2 units by 2027. For comparison, that's more than the peak production of the Volkswagen Golf, one of the industry's greatest successes. And what makes this even more impressive is that the investment required to reconfigure each Tesla factory is estimated at half the amount that traditional automakers usually spend to launch a new model. This provides greater agility and lower financial risk to the operation. Production on a scale of this magnitude also opens up a brutal advantage: economy of scale. With more units coming off the assembly line in less time, the cost per car drops, and this is directly reflected in the final price. Furthermore, the standardization brought by gigacasting reduces maintenance complexity and speeds up repairs, another point that can attract consumers seeking practicality and cost-effectiveness. It's an industrial approach that transforms the very logic of how a car should be built. The short answer? There's not much left. What once seemed like a guaranteed market for combustion cars is starting to become threatened territory. The Tesla Model 2, with all its innovations, isn't just trying to compete with traditional vehicles, it's targeting the heart of the gasoline industry to simply replace it. And not with a luxury supercar, but with an affordable, efficient, and intelligent compact. It's as if Tesla found the system's weak spot and put its finger right there. where most people buy their cars. Imagine this. A family walks into a dealership with a budget of up to $25,000. Previously, the options were basic models with combustion engines and limited technology. Now, that same family can drive away in an electric car with advanced AI, ultra-fast charging, near-zero maintenance costs, and software that evolves over time. And all this without paying extra. It's no longer a choice between luxury and economy. It's a logical and inevitable exchange. And here's the point that bothers traditional automakers the most. They simply aren't prepared to compete in this new field. While they spend billions trying to electrify old platforms or adapt obsolete factories, Tesla already has a modular, scalable design tuned to the demands of the future. And this lost time could be fatal. Experts estimate that brands stuck in traditional assembly models are failing. 5 to 7 years ago, Tesla in terms of adaptability. Another crucial detail is that the Model 2 breaks a long-held narrative that electric cars are slow to recharge, expensive, and have limited range. When an affordable model charges from 0 to 80% in 10 minutes and offers competitive range, the excuse ends. And when this happens, combustion-powered cars are exposed for what they really are: noisy, polluting, and expensive to maintain. Public perception changes. And when this happens en masse, there's no going back. The risk for conventional automakers is that they will be seen as stuck in the past. And more than that their products will no longer be desired. Because there's no point in having a century-old tradition if the new consumer looks at a car and thinks, "Why would I pay the same for something that's less safe, more polluting, and outdated in technology?" The Model 2, with its promise of intelligence, agility, and efficiency, starts to seem like the natural choice. And it's not just a technical comparison, it's a new lifestyle. While a combustion engine car requires frequent trips to the gas station, oil changes, and heavy maintenance, the Model 2 updates itself via Wi-Fi, like a cell phone. It learns from its mistakes, improves over time, and can even receive new features without the owner needing to change cars. This creates a bond with the vehicle that goes beyond the mechanical. It's almost emotional, and that's something no V8 engine can offer. Traditional automakers are trying to catch up with electric launches, but they struggle with high costs, low margins, and a rigid production base. Some even manage to launch interesting models, but they always struggle with the final price. Tesla, however, has reversed this logic. First mastered the supply chain, then refined the assembly process, and is now attacking volume and price, which is where it really hurts for rivals. It's like watching a predator who's already figured out where his most vulnerable prey is. At this point, the question that begins to echo in many people's minds is no longer, "Can Tesla do this?" but rather, would you trust your life to a $21,000 self-driving car? Because we're not talking about just any Tesla. We're talking about an affordable car with cutting-edge artificial intelligence made for the masses. And this proposal, impressive as it is, still sends shivers down the spine of those who grew up with the idea that a good car is one you control with your own hands. But what if that belief is about to change forever? The younger generation is born connected, accustomed to trusting their data, privacy, and even financial decisions to algorithms. For this audience, handing the wheel over to an AI doesn't sound as absurd as it might seem to those who learned to drive in a time when radios were analog. And AI 5, with its data, numbers, and real-world tests, isn't just a promise. It's a technological leap based on concrete results. It's not blind trust. It's trust based on facts. And most importantly, it's a choice that will soon no longer be optional. The price, of course, greatly contributes to this acceptance. $21,000 for a car with autonomous driving capabilities